Okay, in this video, let's talk about how to conduct hypothesis test for one sample proportion. So, the same 4 steps as what we have seen before. First, establish the null hypothesis and alternative hypothesis. Again, the null hypothesis is always going to be something with the equal sign. And the alternative hypothesis could take 3 different formats: greater than sign, less than sign, and not equal to sign. The second step, check on the conditions. So there are 2 conditions in order to do this hypothesis test. First, you have to have a random sample. Second, your sample size needs to be large enough. And how large is large enough? That is when your n times your p now greater or equal to 10, and n times 1 minus p now greater or equal to 10. This p now is this null proportion that you establish in your null hypothesis. So please be careful, it's p now here. There is a common mistake that I've seen before is they use the p hat, which is the sample proportion when checking the conditions. That's not correct. You need to use the null proportion that you are establishing here. Now, after we have the conditions met, we will calculate the sample z test statistic using a formula like this. And again, here is p now, here is p now in your denominator. Step 3, identify the null distribution. This is a standard normal distribution. And then you find a p-value. Then you use the decision rule to reject or not reject your H null. The last step, state conclusion in the context of the alternative hypothesis. Now let's take a look at an example of how we could do it. Again, if you haven't read the example yet, please pause the video here for a second and then resume. Okay, so for part 1, in this example, we try to see whether if this person which does really provide significant evidence of psychic abilities. So the first step, establish the null hypothesis and alternative hypothesis. Remember, we said the null hypothesis is always going to be something with the equal sign. That's nothing is new, nothing is happening. We are protecting what's going on here. So the null hypothesis is the subject is just guessing. The subject doesn't have any psychic abilities. Okay, he just or she is just randomly guessing those symbols. So that means the proportion that he could get it right is 0.2 because there are 5 different symbols. The alternative is the subject does have psychic abilities. So the subject is not just guessing. If the subject does really have a psychic ability, then you would want to see the proportion is greater than random guessing of 0.2, right? So the alternative hypothesis will be p greater than 0.2. Here, our p represents the true population of cars the subject correctly identifies. That's the first step. Establish the null and alternative hypothesis. Second step, check on the conditions. So first, it needs to be random sample. So if the cars were shuffled, then this will be equivalent to random sample. So that is, okay, the first condition is met. The second condition, the sample needs to be large. So we need NP now, which is 100 cars, and our P now here is 0.2. So it's 100 times 0.2, that is 20. This is greater than 10. And N1 minus P now, which is 100 times 1 minus 0.2. This is 80, and this is also greater than 10. So the conditions met. Then we need to calculate the test statistic. The z-test statistic has a formula like this. So this formula here, p hat, the sample proportion, so it correctly identifies 30 of them. So the sample proportion is 0.3 minus p now divided by square root of p now times 1 minus p now over sample size 100. This is 2.5. Now, then we need to find the p-value. So a standard normal distribution, what is the area under the curve that is greater than 2.5, because this p-value is a greater than sign. So p-value is probability z greater than 2.5. That is 0.006, which is less than our alpha. Our alpha is given it's at 1% level, so we reject it now. Then we could write our conclusions, in a way we usually do, to write the conclusion for the hypothesis test. We have statistically enough evidence that the person is not just guessing. This is for A. For question part B, if we try to calculate a 95% confidence interval without knowing the exact sample proportion, in order to get the MOE equals 0.1, what is the sample size we need? So the margin of error is Z times P hat 1 minus P hat over N, right? When you try to calculate the confidence interval. This Y equals 0.1. Now, we are trying to calculate a 95% confidence interval. So our Z critical value will be 1.96. We don't know what is the sample proportion is. So in order to solve for this M, you need to have something plug in the numerator, right? Since we don't know what the sample proportion is, we are going to use 0.5 because that's the when this is largest. That's when we could find the smallest n that we need in order to satisfy this 0.1 here. So we plug in p hat equals 0.5 over n, and we solve for n. We will have our n equals 96.04, and we are always going to round it up to the next integer because we want to make sure that we have enough sample size. So even though it's 0.04, we still round it up to 97 here. So let me summarize it again. In order to find the sample size n, given the margin of error and the confidence level, we are solving n from this formula, right? If you have the sample proportion p hat, then this will be like this, right? We square it on both sides. Then we solve for n equals to this. If you know your sample proportion, you will just plug in your sample proportion here. But if you don't know your sample proportion, you will need to plug in p equals 0.5 when you will make this the largest. So you will have enough sample size n to satisfy your MOE equals to 0.5. Okay, I will stop the lecture here for this video.